Hello friends, today we are going to see another ML algorithm, that was K nearest neighbor. It was shortly called as KNN algorithm. This is unsupervised learning algorithm, and this algorithm can be used for both regression and classification. And this algorithm is mostly affected to outliers. This is the big disadvantage of this algorithm. Let's see how this KNN algorithm classify the both classification problem and regression problem. This algorithm is so simple, we can easily understand this problem, and then it is a non-parametric algorithm, and then it make decision based on some distance formula, by using some distance formula. Let's see how this algorithm will work on classification. Let's take an example. There is two-dimensional plane. It contains some data point. The data points are have two categories. For example, this here there is some data, and here there is an data points. Okay, this both data points are the data points are belongs to each one of the class. These data points are representing a one class, and these data points are represent another class. Okay. For example, whenever we use this algorithm, we want to define a k value. What is k value? Let's see why this k value is important. Depending upon this k value, changing this k value, we can get a very accurate output, or we can say like that, we can get a better output or better prediction from this algorithm. So we need to select k value so accurately, and this k value should be a odd number. I will tell why should this number should be in a form of odd. Okay, let's take a point. For example, we have a point that was present here, but we did not know this point is belong to this group or this group. By using this KN algorithm, we can find whether this new point is belongs to this category or this category. By in KN algorithm, they will find a distance between nearest points between the point. For example, we want to, here is the new data point, we set k as 5, so that first we need to this algorithm will find the first 5 nearest point. This is the new point, so the nearest 5 point is this one and this one, this one, this one and this one. So there are these are the 5 points that nearest to the new point. Okay. So from this, totally there are 5 points. 3 points are belongs to red and 2 points are belongs to blue. So from this, the red point is very closer to the new point, so that this algorithm classify that, or this algorithm predict that this color this point is belongs to this red category, and predict this point is belongs to red. Like this algorithm will predict the input data, predict the output data from the input data. Okay, but how this distance is calculated? And we have another question, why we define k as in a form of odd number. For example, when we sell k as 4, in some cases we will get output as the nearest 4 points are belongs to 2 is belongs to red and 2 is belongs to B, so that the new point nearest 4 point are these 2 red point and these two blue point, so that the algorithm cannot find whether the new point is belongs to this red category or to this blue category. So that whenever we selecting a k as in a form of even number, in some cases we cannot made an conclusion, so that we need to select k in a form of odd number. Okay, how does the distance between 2 points are calculated? There is we can use two type of distance formula. One is the KNN will use two type of distance formula, the Euclidean distance, and another one is Manhattan distance. For Euclidean distance, we use the formula was k2 minus, let's take there, here is 1 point and here is 1 point. To find distance between these 2 points, the KNN the Euclidean distance will find a distance, a direct distance between them from this to this. For example, this point is P1 and it is represented as x1 comma y2 y1, and this point is Q, consider as Q, and this point is representing x2 x1. we can find distance between these 2 points. We need to apply equivalent distance. For equivalent distance, the formula was x square x2 minus x1 whole square plus y square minus y1 whole square, and this whole condition under the square root. This is the equivalent distance formula to find distance between 2 points, and that is another distance formula. By using Manhattan also we can find a distance between 2 points, but the distance is not a direct point. First it will make a triangle. It will find distance between these two this point and then these two this point, and add this two distance and give the output. To predict this distance plus this distance, we use formula as x1 minus x2 modulo plus y1 minus y2 modulo, and we need to add up these two distance to get a distance between P to Q by using Manhattan distance formula. By this only the distance between 2 points are calculated. Like this only this KN algorithm will predict whether this new point belongs to this category or this category. Like this classification problem was done. Let's see how this happen in regression. This algorithm is work on regression. In regression formula, let's take another 2D chart and data are present here. This was a classification problem. So the data are like this scattered. We need to predict, and we need to predict here. We have a new point that was here. We need to find we need to predict what is the output for this point. Let's consider. First we want to define the k value. Here we can define as phi, and we need to find the output for this point. We already see a classification problem. It will first find nearest k point. Like this in regression also it will find k number of points nearby the new point. For this, these are the nearest 5 point. This then for this point, this have an output. Already it's an output. This all 5 point having already a output we have. It will find mean of all the nearest k, nearest neighbor, and this mean value is defined as the output for this point. like this only the regression problem will be done by using KNN algorithm. And already we saw that this algorithm is mostly affected to outlier. Because whenever we got a output, we get a new point and we need to predict whether what will the output for the this point. We try to compute, first we need to compute a distance between this new point and the nearest 5 point. Whenever computing, we use Euclidean distance formula. Whenever whenever this data point is so further from the another points, this value will be I. Whenever we squaring up these values, we will get a more value, so that this algorithm will affect to calculate the distance between these 2 points. This is the biggest disadvantage of KNN. It will easily affect to outliers. Is basically the KNN algorithm is straightforward and effective for many classification and regression tasks. It simply simplicity and flexibility with different distance matrices and interpretability make the KNN so useful for various scenario, and it can be compute instance of large data. By instead of using large data, it will use a k value, only the k value, and classify and predict the output data for an input data. To find the best value of k, we can use a technique called cross validation. By using cross validation function, we can find which is the best k value for an KNN problem. Okay, then this algorithm was an instance based learning. The KNN store all the available data and classify a new data point based on similarity measures. Similarity measures means here we uses Euclidean distance. By using this Euclidean or Manhattan distance, we using these two distance formula, we will simply classify the output, and it does not build an explicit model, but it replicate its entire data. It just replicate the entire data and have some copy. Depending upon that, in a batch wise, it will perform distance function, and then it will give the output. So that this algorithm is uses worked on instance based learning. That means it instantly calculate the distance, and depending upon the distance it will give some output. And because of that, this algorithm is worked on based on instant based learning. Okay, I think you all understand this algorithm, how does it will work. We can see another algorithm in another video. Thank you.